I just wanted to talk about some of the benefits and necessities of creating software that verifies that your software isn't breaking or changing too much. You're basically just writing a script that's making sure that whatever attribute or variable that was a Boolean before remains a Boolean, so you're not switching to using integers for something or so on or so forth. So it's all about developing these contexts and really specific contexts in which you think you can catch errors that might change. So you usually want to just attack the areas that are most prone to change, or the good areas to explore first when writing a unit test. Now, there are two kinds of unit tests. There's doc tests, which I like to use for really simple unit testing. Like if you have something that's a static function that takes one thing and another thing, and no matter what, those two things always output the same result, then you could write a doc test, which we'll get into. But sometimes things are more complicated than that, and you either need to statistically verify that what you're doing is correct, or you just need some sort of dynamic way, like let's say you're working on a Flask project or a web dev project. Well, you're not going to run a server through doc strings. So I have an example script that I wrote, and it has a meta class animal and a subclass of dog, and I also have a coin flip. Okay, so I made this really simple application that just has an animal class, and the animal class has a name and a sound. I have a dog subclass. Dog's name is dog, and it goes woof. And then we have a make noise method, and it just says the blank goes blank. So here's an example of a doc test. And it's one of these examples of if you are sure on what the input is and you're sure what the output is, it's optimal to put in a doc string, because not only are you writing a unit test when you put it in a doc string, but you're also writing the example of how to use it, which doubles as really useful for like an API guide, or just when somebody's looking at your source code and they have to interact with a piece of, like a method that you wrote or something of the sort. They can just look and see, oh, well, I use dog.noise, and then it outputs this. So where tests come in handy, I'm using this module called doctest. And if you're using py.test, which is pretty conventional, I think we seem to pretty universally use it for Python, you can set it up to also test doc strings automatically. So like when you run py.test, you can run the unit tests, and then you can actually run the doc tests as well. So one example I wanted to give was, you know, what if we change how names or sounds are represented? Like, what if we wanted, like, capital D for dog? We can run our test, and then we can see that from the doc string, it was saying that in my doc string, dog.makeNoise was given an example to say the dog goes woof. But what actually happened is the dog goes woof with a capital D. So like minute changes can help you catch breakage on just little stuff like that. And the whole point is, when you're developing software, it's usually going to be hugely interdependent on everything. Like, rarely are you writing something that's just kind of like this end result and nobody touches it from there. Like, you're writing something that a bunch of other people are going to be interfacing with, and if you have these structures where a lot of people are depending on your code, it's really important to make sure that it's not randomly breaking in various cases. You can do fancier things with doc tests. I made this thing called the coin flip class, and all it does is it's a random integer, 0 through 1. I said a heads is 1 and 0 is tails. So one thing we can do, let's give an example. And we can say, oh, did I not have that? Okay. Does everyone know what the magic method represent does, the REPR? Okay, so if I do something like this, if I try to present coin flip as a string, it's just going to return the value. So if you've ever printed a class, and you've probably seen something like this. So it's just a way of representing the class and its value. But anywho, if we want to give an example of what this toss is actually going to be, we can't predict what the number is going to be in the example. And unless we want to use some kind of hacky, there's like docstring comments you can use to say this test doesn't count. We can do something better and do something like this. And then the ... is basically like a wildcard match. So if you're not sure what data is going to go there, you can say, well, just verify that it's this, and then in the ... region could be anything. So let's actually run this to keep me honest. This is the line that's actually testing the modules. Usually you just run py.test and it'll do that for you. Oh, so we already got an error. The first one is we need to correct this to be uppercase, and the second one is that I actually got this instead. Was it? Yep. So after those corrections, oh, huh. I'm not sure why the ... isn't working on this machine, actually. Am I not seeing something? Usually the ellipses works. I'm not sure why not in this context. I have it on a few repos like that. Anywho, so there are ways to take care of variable data. It's in the doc.test module somewhere. Instead of reading the documentation for the Python doc tests, I find it's far more useful to search Python module of the week doc tests. And then there's this really great guide on how to thoroughly use doc tests. So they give you really basic examples, but then they give you stuff that's a little bit more complicated. Oh yeah, see? Huh. I don't know why that's not working then. At any rate, so those are just really typical static ways that you can interpret what's coming in and what's coming out. But you have more complicated situations like, okay, let's actually verify that coin flip is random. What did I call that? Oh, okay. Here's my tests file. It's where my more complicated unit tests go, like my py.test unit tests. And it's like what I was talking about earlier, where it's just software that you write to validate that your code works as expected. So inside this, I import my module that I'm testing itself, and I also import py.test. Now, you don't necessarily need to do anything with py.test, nor necessarily even need to import it, but it does give you tools like if you want to assert that a certain exception is raised in certain cases, they have that availability. The documentation's on their website. It's pretty thorough. Here's an exact example of how you do that. It's a context statement, and you just say, here's the error that I expect to get from doing this. And then, in my particular example for testing the coin flip, I did a probability check where I have a sample size that I can define, and I just said 1,000. And then I have my acceptable margin, which I said 10, because the Python random int is really bad. And from there, I just count the number of times the heads are flipped, and then the number of times the tails are flipped. And then all of this is just calculating the percentage difference. And if it's over the acceptable margin, I can tell py.test that the test failed. Now, this is a more complicated use scenario, but I wanted to give an example of what unit tests are really good for versus what dot tests are really good for. If you have a lot of stuff that's dependent on context, a lot of stuff that requires on setting stuff up, a lot of stuff that's dependent on building tests dynamically, you want to go with unit tests. But again, if it's like static and obvious, in, out, then you just want to use the dot tests because it doubles as documentation. But if you want, I don't necessarily find any harm in putting everything just in the py.test module. It can make things easier. But it is nice to have like little code examples in doc strings. I think that's pretty much the most complicated thing. I'll show off what happens if, say, it would probably be smarter if we changed coin flip. Instead of a 0 or 1, one thing that we could do to make it a little better is maybe say like self.heads equals something like that. So we just changed the structure of the coin flip so that heads will be true or false, and then tails is going to be the opposite of heads. And if we run this, it will break a lot of things, like the represent part isn't going to work. And it will also tell us, oh, here's another thing. It's really good to be as specific as possible when you're writing tests. Like, don't just say, if this has a value. You know, like you can do Boolean operations on just about any data type, or condition. So you can say like, if coin toss, and coin toss is 1, it will validate to true, but if it's 0, it will validate to false. You want to explicitly state, if coin toss equals 1, or if coin toss equals false or true. So you're always doing the type checking for your application so that if the type does change, your test is going to notify you. So be specific as possible. Statistics are cool when building your application if it's really variable. Or if you're doing networking stuff, it's really handy. I think that's about all I'd want to say about tests. Yeah.